In the previous video, I introduced you guys to the law of cosines, and I went over the basic formulas and what types of triangles that we're going to be using here. So specifically, it's important to remember that you can use the law of cosines for either an SAS or an SSS triangle, so one of those two triangles. And I'm going to be solving for two examples. I'm going to be solving for a side using a SAS triangle in a SAS case. And then I'm also going to be solving for an angle in an SSS case, where I have a triangle where I know all three sides. So let's start with the SAS triangle here. So we have a case of an SAS triangle. So we have our SAS triangle. What information do we know about this triangle? First, let me draw this triangle here. Actually, let me cut that. Alright, using the law of cosines in 3, 2, 1. In the previous video, I went over the law of cosines, including the formulas for finding side lengths and angles, and I also went over the fact that what triangles that you can use the law of cosines and the law of sines for. So right now, I'm going to be focusing on two examples using just the law of cosines. Since I already went over an example of using the law of sines, since it's a bit more simple. Remember, this is in two parts just because the law of cosines, there's more to it than there is the law of sines. So the first example, we're going to look at an SAS triangle. So we have an SAS triangle. Now we know side A, so we know side A, we're going to denote by A, is equal to 9 centimeters. And then we know side B is equal to 11 centimeters. All right. Now we want to find, we want to find side C. So side C is a mystery, but we have angle C, and angle C is equal to, here, let me write that a bit neater here. So we want to find for side C, and then we know that angle C is equal to 47, it's equal to 47 degrees. So that would look a little something like this. Let me start with our simple triangle here. So we want 47 degrees, all right? And we'll say our triangle looks like this, all right? So we have this angle, and we're going to say this is angle C. So this is 47 degrees. So this is angle C. And then this is side C. And then we're going to say this is angle A. So this is angle A. And this is angle B. And we know this is side B. And we know side B is 11 centimeters. And we know side A here is 9 centimeters. So this is an ASA triangle. In fact, let me rewrite this real quick. So this is an an SAS triangle, excuse me. This is an SAS triangle because we have a side, another side, but between the two sides that we know of, there's an angle that we also know the value of. So it makes an SAS triangle, if that helps a bit. So let's solve for side C here. So if you remember anything, and I hope you maybe took note, jotted down in a notebook, if you remember the side length equations to find sides for using the law of cosines, if you remember, it was something like this. It was a squared is equal to b squared plus c squared minus 2bc times cosine a, and then it was so on and so forth. So for this example, since we already know for side A and we know for side B, we're not going to use this equation. In fact, we're going to use the specific equation. We're going to get a little specific here. We're going to use the equation c squared is equal to a squared plus b squared minus 2ab times the cosine of angle C. So let's set this equation up and substitute our values in for A, B, and angle C here. So we're going to say side C is equal to A squared. Well, A squared, we know side A is 9. So 9 squared is equal to 9 squared plus, well, B squared is 11 squared because we know angle B. This is side B. So side B is 11. So B would be 11. So 11 squared plus 11 squared minus, and then 2AB. We know A is 9. So 2 times 9 times 11 because we know B is 11, and we're going to multiply by the cosine, let me do that a bit better here for you, the cosine of angle C, but we know angle C is 47 degrees. So this is our equation, and using a calculator I'm going to simplify here, and in fact I don't need a calculator for some of this, but C squared, this is the same thing as saying C squared is equal to 81 plus 121 minus, and then 2 times 9 times 11, I'm not very fast at mental math, I'm going to be honest, minus 198, so minus 198 times the cosine of 47, that's supposed to be a 7, 47. And then this is the same thing as saying C squared is equal to 202, so 202 minus 198 times cosine of 47, and then we're going to say, now if I were to do 202 minus 198, then we're going to multiply by cosine of 47, that gives me about, this is all equivalent to about the square root of 66.964. So C squared is equal to, 202 minus 135.0.036, and I'm getting pretty precise here, and this is equivalent to, and in fact I'll just write it down below, and then we know C squared is equal to 66.9, I'm just going to say 66.9, and we can get the square root of the entire thing to solve for C, and this is equal to C, and C is approximately 8.19 centimeters. And I say centimeters because we're using centimeters. In fact, let me write that a bit neater for you guys. 8.16, or 19, my bad. 19 centimeters. So now we solve for the side, and we completed our task of solving for side C. So now we know side C is equal to 8.19 centimeters. And that's how you can use the law of cosines to find a side of a triangle. But now let's look at finding an angle of a triangle. And typically you would do this in a SSS triangle, and that's exactly what I am going to be doing here. So let's look at a SSS triangle here. So we have an SSS triangle. Side A is equal to 7 centimeters. Side B is equal to 8 centimeters. And side C is equal to 9 centimeters. We'll go in a little order here. Now we want to find the measure of angle C. So we don't know the measure of angle C. So let's draw a triangle here. There's going to be a bit more math involved in this. It's going to be a bit more involved because we got a bit more steps to take here. So we got our nice little triangle here. And we're going to say this is 9 centimeters. This is 8 centimeters. and this is 7 centimeters. It doesn't look like it. It's not super realistic, but we'll just say it is. So we know this must be angle B, and then this is angle C. So we want to find for this angle here, and then we know this is angle. This must be angle A here. So we're going to try to find for this angle C here. So if you actually remember, and I hope you also jotted this down when you were going over, when I was going over the law of cosines for finding the angles, returning an angle, is the equations for that. So we're going to be using the cosine of C, angle C, because we're trying to solve for angle C. And this is going to be equal to a squared plus b squared minus c squared, and I'm just going to use my line tools for nice perfect line, and it's going to be divided by 2ab, so 2ab. Now let's substitute all these values into here and solve for this. Alright, so we can rewrite this as cosine of angle C is equal to, well, we know A is equal to 7, so 7 squared, plus, and then B, so side B is 8, so 8 squared, minus C, and we know C is 9, so minus 9 squared. And then we're going to divide it, we're going to divide that all by 2ab, which would be the same as saying 2, we know A is equal to 7, so 2 times 7, and then B is 8, so 2 times 7 times 8, and this will become that. Now, we're going to simplify this to that, and you're going to get a perfect ratio, so 7 squared plus 8 squared minus 9 squared is equal to 32. So 32, 2 times 7 times 8 is equal to 112. So 32 divided by 112. And this is our ratio. But now, if you remember from the introduction to arc functions, this we're trying to find for an angle. And we have our side ratios here in for this. So now you're going to rewrite this, and you're going to say arc cosine, since you're trying to find an angle, and you use the arc functions to return an angle. You're trying to find an angle, so you use the arc functions. So arc cosine of C is equal to 32 over 112. You could also rewrite this as cosine negative 1 of C is equal to 32 over 112, and this all totals out to approximately, and I can do that here, so arc cosine of 32 divided by 112, and that's approximately 73.4 degrees. So let me do that a bit better. 73.4 degrees here. So now angle C, we solve for angle C. We know angle C is approximately 73.4 degrees. And that is using the law of cosines to solve for a side and to also solve for an angle of a triangle. I hope this helps you understand the law of cosines a bit better, and I hope this is a better representation and visual for the law of cosines, and helps you understand why the equations are set up the way they are.